Okay. Yeah, ready?
All right. So, just want to give you a heads up on what we have to do. Essentially, we are done with all the topics that we were supposed to get done, which allows us a little time for working with quadratics. Okay. This unit is, we've already done some of this unit. We've already done solving quadratics. We've done some simple quadratics. We've done some quadratics by taking the square root. We've done very basic factoring. We're going to take all of that stuff and we're going to take it a step further. We're going to do more complex factoring. We are going to do graphing. We are going to do some modeling. You are, at the end of this unit, you are going to, your project is going to be to create some type of machine, simple or complex, that is going to throw a tennis ball. It can be something as simple as a slingshot. It can be something as complicated as a catapult, if you will. You can make a beer can, I don't care. The only restriction is that it has to be limited to throwing the tennis ball less than the distance of the soccer field. Because you are going to go out, you are going to video the path of your tennis ball, you're going to measure the length of the path of your tennis ball, and you are going to come up with a quadratic that fits that path of the tennis ball. And then you're going to match that against the theoretical path. Yes?
There's a group shot.
Individually. If you're going to do a group, it's going to be only one other person. Okay, but you're both going to be required to do the work. Okay, so if you come together with a partner and you make a catapult, you do your tennis ball, they do their tennis ball. So you're each going to have your own path. You cannot use the same path.
So sorry, you guys can copy of it.
I know, so you're going to actually have to use half of your own brain. So, like I said, it can be a simple machine. If you don't want to create a machine, you can throw the tennis ball. That's up to you. I don't care. It all comes down to the same thing. So if, like I said, if you can get as complex or as simple as you want with this, the machine is not the project. The machine is, or the project is actually mapping the path of the projectile. Okay, and then we're gonna compare the theoretical path, the formula that I will give you for that, with the actual path and see what the difference is. Okay, so that's at the end. To build up to that, like I said, we're going to do factoring polynomials, specifically quadratics. We are going to do solving some quadratics, a little bit more advanced than we've already done. We will do graphing quadratics. We will do all of this by hand. We will do this by paper and pencil. I will also give you some data points, and you will have to come up with the equation of the quadratic. I will give you the equation of the quadratic. You will have to come up with specific points on the quadratic. Both again by paper and pencil and by hand. So we're going to be working both with your calculator as well as with paper and pencil for this entire unit. Now, that being said, we got to start somewhere. And if my computer
You can look at that. Someone drew a picture of Emma so you can remember what she did.
that doesn't look right. That's 0%. All right, just give me 1 second. My computer froze up and it doesn't want to play the PowerPoint. All right. Now we've done a little bit with quadratics. So, how did we solve quadratics before? How do you factor? Okay, reversal of your FOIL and your GCF. Those are the basics. Now, we did some very simple factors. We're going to review that factor today, and then we're going to take it a step further. After today, you will be able to factor just about any quadratic that is given. Okay.
GAB, I never heard of that. GB, I told you, if you're smart, then you
Okay, GCF.
Okay, so I will tell you that this PowerPoint was made on a PC, so not everything comes out extremely clear. So just bear with some of the things that don't come through. Okay, this is a review PowerPoint that I've used before. So it's assuming some of the things that you guys already know. Some basic factoring, some progressions, some of the foundations. Stuff that we've already gone through. There is a progression every time that you go through factoring. What's the very first thing you look for when you're factoring?
GCF.
What does GCF mean?
Greatest common factor.
What does that mean?
Largest value of the factor that
Largest value of the factor?
largest value that goes into two numbers.
Just two?
More than two.
So three.
Two or more. Two or more.
Two or more. So there's the largest factor, the largest value that goes in. What's a factor?
Something that goes into.
A number you can divide it with.
A number you can divide what with?
The number with.
A number you can divide a number with.
Yes.
Well, I can divide any number by any number.
The number that you can divide the original number with.
I can divide 8 by 5. I can divide 5 by 8.
Exactly.
Whole number goes into a whole number.
What whole number?
Whole number.
What's a whole number?
1, 2, 3, 4,
Without
5,
decimals,
6, 7, 8,
without
9.
decimals.
No, actually a whole number is 0. 1, 2, 3, 4, 5, 6. So instead of saying a whole number, a factor is a number that goes into a larger or any number an even amount of times, okay, without any decimals. All right, so know that. It is important that you know that. A factor is a value that goes into another value an even amount of time. And by even, I don't mean 2, 4, 6, 8, or 10. I mean without any leftovers, no remainders. Okay, so the very first thing we always look for is our GCF. Okay, so we always look for our GCF, greatest common factor. After that, who knows what we look for? Probably don't. You've probably never seen this progression before.
LCM.
Not quite. Okay, so after we look for, oh, we went through 2. After we do the GCF, the second thing that we look for, now this is when we are looking for small polynomials, 2 and 3 term polynomials. You look for a difference of 2 squares. Okay? If there's not a GCF, or if there is a GCF, pull it out, then we start again. Once we pull out the GCF, that doesn't mean that these 2 cannot come into play. I can use all of these if each one of them can be used within my problem. Okay, it's not like, okay, I pulled out a GCF, I'm done. To this point, you probably have only seen those types of problems. Those are no longer. You are not in elementary school anymore. Okay, so Sometimes some of these problems that we're gonna see involve all three methods. There will be a GCF, you'll have to use the AC method, and you will also have a difference of two squares. Okay, so you can have a mix of all three. So be careful. You know what the GCF is, you probably know what a difference of two squares is, hopefully. And the only thing that you don't know is the AC method. Okay, that AC method is also called a product sum method. I call it the AC method just because I like that better. Okay, so GCF, like you said, you simply find the largest number that goes into each term of the polynomial evenly. What's a polynomial?
X.
No, X is a variable.
Like anything to the, no.
X squared.
Yeah, like
It is
squared.
another variable.
Like squared.
That's a term.
Two X squared variables.
Like a number.
X squared plus BX plus C.
What is that?
A
That doesn't tell me what a polynomial is. That
That's
just
a
means.
quadratic.
Say it. Okay, quadratic.
Anything with more than one solution.
Not quite.
Oh.
Pancreas.
That doesn't even make any sense.
Producing bubbles and gallbladder.
Not quite.
Not quite. We're getting somewhere, guys. Come on.
Yeah, you're showing me your lack of intelligence.
One belly button.
You don't have anything intelligent to say, do me a favor, don't say anything else.
Oh.
Including stupid noises.
Oh. But isn't it a number that can have more than one solution?
No. Polynomial doesn't mean that it has a solution. Polynomial is not a polynomial equation. Equations have solutions. Polynomials can be expressions. Okay? What is the difference between an expression and an equation?
Expression or simplified equations.
No. What is the difference between an expression and an equation? Very simple.
Yeah, one has a solution.
Why?
Because it's equal to something.
Because the equation has an equal to. You cannot solve an expression. You cannot find the value of an expression. Okay, or I should say, you cannot find a value of a expression with variables. Sure. Okay, so a polynomial, you might want to write this down. It is a sum or difference of one or more terms. X is not only a variable, it's also a polynomial. 5 is a polynomial. 5x is a polynomial. 5 plus x is a polynomial. 5x plus 3n squared is a polynomial. So a polynomial is the addition or subtraction or the combination of terms. Combination of terms through addition or subtraction. It can be one-term polynomial, it's called a monomial. A two-term polynomial is called a binomial. A three-term polynomial is called a trinomial. And then after that, they do have quadrinomial. We don't worry about those. Okay? So you got monomial, binomial, trinomial. Anything more than that, we just classify it as a polynomial. Now, so find the GCF. We find the biggest number that goes into each term in the polynomial evenly. Okay? So, what's the GCF of 3z squared plus 6z?
3Z.
Easy.
Why?
Because it goes into both things.
What does?
3z.
3 goes into what?
3z squared and 6z.
Ah,
Because for the first one it's times 1, the second one is times 2.
there is a very specific reason why I'm asking you this. You can laugh all you want, because when we get to the next part, and you can't tell me the GCF because you don't know what a GCF is, or why they go into them, then I will laugh at you. Again, refer back to my statement that I just said earlier. Now, the reason that it's 3z, what goes into 3 and 6? 3z.
2, 3, 1.
1 goes into anything. 1 doesn't really help us in this, okay, but it is something that we will use as a common factor. okay? Here doesn't do a whole, so we go higher. What is this 3, by the way? What is that called? What is that thing that sits in front of the variable called?
Oh, I wrote this down.
We learned this last year.
I wrote
You
this
learned this more than last year.
I wrote this down.
Probably learned this in about 6th grade.
I wrote this down. Oh, there.
What is the number called that sits in front of a variable?
Multiple?
What? It starts with a C, and it's not constant. Constant does not have a variable.
Control, really.
See how valuable vocabulary is in mathematics. Coefficient.
Coefficient.
Oh,
coefficient. Oh my god.
So when you look at the coefficient, all right, we have a numerical part of our GCF, and we have a variable part of our GCF. Okay? So the numerical part is the largest number that goes into each of the coefficients. If there were 15 terms, it would have to go into each of the 15 coefficients. It has to go into every single one of the coefficients. It doesn't have to go in the same amount of times, but it has to be the same number that goes into all the coefficients. Now, then the variable, it has to be the same variable, right? It has to be the same variable. What do you notice?
They have the same variable.
And
And
how many did you pull out?
1.
Why?
Because
Because
one has
Because one is
one has one,
square.
one has one Z.
So can I pull 2 Z's when there's only one?
No.
No, keep that in mind. Okay? Be amazed how many people try to pull through 2 Z's from 1. You can't do that. Okay? So right now,
Whoa.
it's 3Z. What about there?
4y squared.
4y squared.
4y squared. Okay? It's the largest numerical coefficient that goes into 4, negative 24, and 20. The largest number that goes into each one of those is 4. Largest y value that goes into y to the 4th, y cubed, and y squared is the smallest exponent. Okay? So the variable goes by the smallest exponent. Right? So that's pretty easy. GCFs, you've been doing GCFs for a while. Just might not remember what they're called. Okay?
We solve it.
Can't solve it, no equation.
You
You simplify.
Oh, don't simplify. What I want you to do is factor. These are simplified. So what I want you to do is a reverse distributive property. I want you to find the GCF, if there is one, and I want you to factor it out.
Rewrite them. We all read each other, man.
We just find these here.
Right? Right?
What? 36. Wait, what?
Wait, what?
Yeah, I quit.
Oh, you can't do the easy one.
No, I can do it.
Oh, then don't quit.
What's the first one?
Yeah, exactly. That's the first one.
Don't know the first one. Take a look at it. Start with the numbers. 36, 81, 45. What number goes with 36,
9.
9. Is there a common variable?
No.
G. So what's your GCF?
T. 9 squared.
So
I said that.
factor that 9G out. What happens when you factor that 9G
Oh, I
out?
know. It was 4G minus
We have
9H plus
9G.
9G.
We factor that 9G out. 36 divided by 9 is what?
4.
G squared divided by G.
G.
Negative, then you multiply it by 9.
9H.
5G squared.
Now what?
That's it.
Oh, what?
Because if you take it the next step further, you dingleberry, if you multiply it back in, where are you gonna go?
Oh, smart.
Because if you multiply it back in, I'm going to simplify this. Well, I told you, it's not a simplifier, you're a factor. If you multiply it back in, you're gonna be right back to where you started from, and then you're no better off than where you started.
This is like a space-time singularity.
Well, that's really, it's called factoring. Okay. What about this one? 22n squared plus 17n to the 5th minus 8n cubed.
X squared.
Only GC.
What do you mean? You can't have, there's no numbers?
No.
1. 22, 17, and negative 8. 22, 17, and negative 8 are what are called relatively prime. Even though 22 and 8 are not prime numbers, they are composite numbers, and they do have factors in common. They do not have any factors in common as a trio with 17 other than 1. Okay? So we call 22, 17, and negative 8 relatively prime. Right? Now, as far as the variable goes, n squared, n to the 5th, n cubed, they do have a common factor. That common factor is n squared. Okay? So we can pull that n squared out. How about this guy?
3m.
There's a lot of stuff going on.
3m cubed.
So we go 3, 18, negative 24, and 30. What number goes into all 4 of those?
3.
3. So we pull that out. n squared,
Oh,
n to the 5th, n to the 7th, n to the 7th. What do we have?
N cubed.
M cubed. Pull it out. What about n?
N squared.
There you go. Okay.
So weird.
1 plus y is equals and
All right. Now it's going to get
I'm not
half a step harder. Half a step harder. A difference of 2 squares. I'm going to test your vocabulary today. What is that? What do you think that means?
No.
the difference of two.
What do you think that means?
He said X squared and Y squared.
What's that?
X squared minus Y squared.
That's it? That's all it means, x squared minus y squared? Well, what's x squared?
X times X.
It's a variable.
Okay, so we're only allowed to have x. Then y.
X squared minus Y squared minus Z.
Get away from these x's and y's or you're gonna have major problems.
A squared minus
Okay? 2 things to be a difference of 2 squares. What's difference mean? What's 2 mean?
2.
Okay.
One.
There can only be 2 terms that are being subtracted. That's one of the 2 conditions. All right? Second condition is that both terms must be perfect squares. And no, that does not mean that they have to be variables. Remember way back in the beginning, before we even did right triangles, I gave you that list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225.
Yeah.
Okay, then we jumped up. I didn't have to memorize 16, 17, 18, and 19, but those are good to know. So then we did 20, 25, 30, 40, 50, 60, 70, 80, 90, 100. Those you better have committed to memory, or you are going to have a very difficult time factoring. Okay? You are going to have a very difficult time. Now, not only the perfect squares are important, and this is where your rudimentary math comes into play, you need to have all your multiples of all numbers up here. Okay? So that means when we go back to that 12 by 12, learning how to multiply any number by any number. Okay? Going up, and really you only have to memorize the 12. Okay? I would probably throw up to 15 in there, but if you can get 12, you should be able to get any of these factors. Okay? So 1, 2, 3, all the way up to 12. Factors or multiples of 12. 12 minus 12. Okay? Should be able to have that. unless you are one of those that relies on your calculator to do all of your calculations, then this is going to be some of the most difficult stuff that you've ever done. Okay? So, very important. Requirements. 2 requirements. It needs to meet both requirements. It's not good enough just to have 2 terms being subtracted to be a difference of 2 squares. It's not good enough that both of them be perfect squares. It must be that you have 2 perfect squares and you are subtracting these 2 perfect squares. Okay? So be careful. All right? Now, to factor a difference of 2 squares, it's very simple. Okay? And this is why you must know that list of perfect squares. To factor a difference of 2 squares, you take the first one, take a square root of it, take the second one, take the square root of it, set your 2 sets of parentheses. First position, square root of the first term. Second position, square root of the second term. Put a plus between them. Go to the second set of parentheses, square root of the first term, square root of the second term, put a minus between them, and you're done. Okay? So to factor a difference of 2 squares, each set of parentheses has, in the correct position, square root of the first and the square root of the second. One of your parentheses has a plus, one of your parentheses has a minus. This goes back to very, very crude mathematics. How do you get difference also means what? And this is where some of you guys have a major problem because you don't see it as this. Difference also means that we have what kind of a number? Negative. Negative. Okay? You have a negative number. How is the only way that we're going to get a product with a negative number?
Positive times negative.
Positive times a negative. Which means one's got to be a plus and one's got to be a minus. If they're both pluses, what happens? Positive times a positive is what?
Positive.
What happens when you have both negatives? Negative times a negative is a positive. Then you don't have a difference. You have a sum. Okay? And you also have a middle term, which causes a problem. So.
Oh,
Oh, there.
it's a question.
That's so much. How long did it take you to make this with all the pre-colors?
Not very long.
Oh.
Because all that is an animation. I don't type in. I don't go out and change the individual.
I did this.
That's why I said it was only supposed to go in highlight, and then it was supposed to stay at this after the animation. Are we good?
Mustafa needs one more. Yeah, we're good.
Thank you. Okay, now, start simple. Factor 16k squared minus 1. Go.
Oh, 4K plus. Wait. Oh, yes.
Okay.
Well, first you need to ask yourself, go through your progression. Is there a GCF? No. Is this a difference of 2 squares?
Yeah.
Yes. What's the square root of the first term?
4K. 4K.
4k. What's the square root of the second term?
1.
1.
Easy like
4k minus 1, 4k plus 1. Done. Okay. Square root of the first term, square root of the second term, square root of the first term, square root of the second term. One has a minus, one has a plus. Done. It is easy.
I still remember this history series well. Oh my goodness.
Okay. 36p squared minus 49q squared.
What? It's getting hard. It's getting hard.
Is there a GCF?
Yeah.
No. So it's a difference of 2 squares. Factor.
Negative. Let's look at this. Should we go to coming house?
Hey, yesterday, I know, had taken to the
You do video.
I wanted to sell it.
Oh my God.
Like,
So we gotta get,
That's my goal. Happy to
okay, what is it?
6p minus 7q.
plus 6p.
Plus 6p.
No plus. Fine. These are factors. What do factors do? Factors get multiplied. We do not add factors. We multiply factors. There's a multiplication between these two. So you have factor of first term, factor of second term. This is a factor of the whole thing. This is a factor of the whole thing. These are two factors. We have to be multiplying them together. Okay, so we got 6p minus 7q, 6p plus 7q. Now, a question comes up. Well, can I put the plus first? Sure. What's 4 times 3? I'm going to assume that was 12. What's 3 times 4?
12.
Does it matter which way we multiply?
No.
What property is that?
Distributed problem.
Wrong.
I mean, commutative problem.
Commutative property. Okay? Okay. Factor 100m squared plus 25b squared.
Wait.
So just do it. We don't need to talk about it right this second.
Wait, we can do that.
Sure.
It has plus.
You know, there
So it is a plus.
is something called GCF. What?
There's a plus in there. So this is what I'm telling you. You've got to pay attention. Is this thing a difference of 2 squares?
No.
No, it's a sum of 2 squares. We cannot factor a sum of 2 squares like we factor a difference of 2 squares. Okay? But
You can make it in different.
no.
Oh,
Can
we can use GCF.
Or you can just pull the GCF out.
Is it like this?
What's the GCF between 100m squared and 25p squared?
This is wrong. 4 squared plus 4md plus.
What is the GCF?
25.
25. So you pull out the 25.
This one, bro.
This is not a difference of 2 squares. So the best thing that you can do,
Not just the answer. Who's right?
the best thing that you can do is write it as 25 times. Well, once I pulled out the 25, what's left? 4m squared.
You're supposed to make it square.
Hey.
Not like
Plus
1.
d squared. Can I factor that?
No.
Yes.
No, you can't.
Perfect square, perfect square.
Exactly. So you make it square. It's
No.
the difference. You make it full square.
Nope. Cannot.
You can simplify.
No, you cannot.
But
No.
but can you
Nope.
but
Nope.
it's like-
Nope.
No.
you can leave it.
Because if we go back to what you just said with Miss Rice series, I remember Miss Rice series foiled. If you take this 4m plus d, and you have 4m plus d, that is that 4m plus d squared that you so badly want to do. It's completely wrong. What's 4m times 4m?
16m squared.
No, do it.
Oh, fine. You want 2 then. So what's 2 times 2?
4m squared.
Oh, great. Now, that's the F. What's the O?
I forgot. 20.
2m
Oh,
times D.
Chinese.
What's inside?
I'm very
2md.
Plus d squared.
And then the last plus d squared. Your method gets 4m squared plus 4md plus d squared. Where did that number come from?
From
From, pay attention. Don't make those mistakes. That's a very common mistake. Ladies and gentlemen, exponents. This does not even closely mean the same thing as this. They're not even close to being the same thing. Okay? This square is only on what?
Only on 4.
No, it's not.
M.
It's only on the m. It is not squaring that 4.
Yeah.
It is only squaring that m.
I agree.
This square is what?
On D.
What is that square of?
X squared.
What is this squared on?
4m plus.
The whole quantity 4m plus d. They're not the same.
I think there's a time. Gotcha. 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 You know what that means? Gotcha.
Okay, here we go.
This is basically analyze.
Now, this
AC method. AC machine.
This AC method.
It's not.
Yeah, I can assure you, if you don't give this your 100% attention, you will not be able to do this. So I don't mind laughing and joking, but now it's time to get serious. You have not done this before. Okay? So AC method assumes this, that you know ax squared plus bx plus c, or it is in the form am squared plus bmn plus cn squared. Whatever your variables are. Okay, it can show up in one variable, or it can show up in two variables. A, B, and C are what?
Numbers.
Coefficients. Okay, so this AC method deals with multiplying and adding your coefficients. So be careful. Okay, very first thing is that even before you do anything, is that you get it into this form. Okay, you get it either in the ax squared plus bx plus c form, or whatever your variable is with the highest power, highest degree to the left. Okay, or if you have two variables, get the squared on the first and third term. The common term is in the middle. Then pull out what is A, what is B, what is C. Some of you guys need to pull that out and you write it. Some of you guys can keep it in your head. I don't care which way you do it. All right? Then once you've got that, then you multiply. And this I'm just going to tell you, just write down these steps. They're not going to make much sense until we go through a problem. Then you multiply the A and the C, whatever those values are. You take the A and you multiply it by the C. Just the coefficients, not the variables. Okay, so you take the coefficient A multiplied by the coefficient C. When you do this, you will get a number, obviously. Okay, that number is the one that we're going to concentrate on. Now, we take this product, A times C, and we find two factors of this product that give the sum of B. All right, so we take A multiplied by C, get a number. A numerical value. Then we use our RAIN, and this is where all of our factors come in, our 12 by 12 multiplication matrix, and we figure out two numbers that multiply to give us this product AC, but add together to give us B. Once we do this, okay? Once we do this, okay, this is the beauty of Macintosh, it just doesn't like anything else. Okay, rewrite the middle term now as two factors. So you're going to take one of these. How many terms are there in both of these?
2, 4, 1, 2,
3. 1, 2, 3. 1, 2, 3. Now, this middle term, I'm going to rewrite that middle term as two numbers. Now, how many terms is our polynomial going to be?
2, 4, 1,
4. Be 1, 2, 3, 4. 1, 2, 3, 4. We are rewriting this middle term. Do not add them back together. Okay? Or you get back into the knucklehead situation that you did earlier. If you add these two terms that we just created back together, you're going to get right back in here and you're not anywhere close to factoring this thing. Leave them as 4 terms. Once you do this, if you do this correctly, every single time, the first 2 terms will have something in common, the second 2 terms will have something in common. Okay?
Oh, right.
Okay? If we have two terms, the first two have a GCF, the second two have a GCF, we pull that GCF out of each of those two terms. Right? Again, just write this down. Okay, it's not going to make much sense until we do a problem. Now, if you've done everything correct up to this point, what is going to be left inside the parentheses is now another GCF. Okay? You will factor this parenthesis part out as the GCF. Okay? So you're going to factor out the parenthesis part as the GCF. And you will be left with your two factors.
Okay.
And obviously disregard the numbers. Very good. Okay, good. Now, factor 3p squared minus 7p minus 6. Go through progression. Is there a GCF?
No.
No. 3, 7, and 6 are relatively prime. Is this a difference of two squares?
Yeah. No.
No. There are three things. It cannot possibly be a difference of two squares. So, the only thing left is to do our AC method. What's A?
3.
What's C?
-6.
Negative 6. So if A is equal to 3, C is equal to negative 6, A times C then is
-18.
negative 18. What's B?
B is 7 over 7. B is -7.
B is equal to negative 7. So now B is equal to negative 7, we find two numbers.
9 2.
9 and 2.
Negative
9 times 2 is 18.
-9 and positive
9 times 2 is 18, but we don't want 18, we want negative 18.
-9 plus positive 2.
Negative 9 and a positive 2. Well, negative 9 times positive 2 is negative 18. Negative 9 plus 2 is equal to negative 7. This is what I want. This one was fairly easy. Now, in the future, you might only have one option. Okay, one set of factors. Actually, each one might be two, but if it's a prime number, you're only going to have one set of factors, the number and 1. But some numbers, you're going to have a long list of possible factors. Only one set of those factors will work. Okay? Because we could have done -2 and positive 9, -3 and positive 6, -6 and positive 3, 1 and negative 18, -1 and 18. None of those other ones work. This is the only one that works. Okay? So sometimes we get lucky and that's the first one we check, sometimes not so much.
Sometimes we use the
And yes, the more practice we get, the more comfortable you are with your multiplication. Now.
No, man, I don't like that.
So now,
It's very less.
no, it's not LCM. You're not doing LCM. Okay? Now, we took this original. Pay attention. We took this original, 3p squared minus 7p minus 6. We found the two factors. Now I wrote my middle term as these two factors. No, you do not add them back together. Because if you add them back together, you right back here, you're nowhere better off. What?
3p.
3p what?
3p for the first one.
3p for the first one, what?
GCF.
We put our first two together, we find our GCF. We put our second two together, we find our GCF. Okay? So yes, out of these first two terms. Now, what we are doing at this point is now factoring by grouping. We are factoring by grouping. This is something that you will do further down the road in calculus. Okay? So we're going to factor by grouping. We're going to put these two together, we're going to factor. We're going to put these two together as factor. Could I put plus 2p and minus 9p there?
No.
Yes. Because these two, okay? Because these two would have a common factor. These two would have a common factor. It does not matter which order you put them in. Okay? Don't worry about that. No matter which order you put them down in that middle term, they will always have a GCF if you have the correct factors. So we put this as rewriting that term. Now we factor by grouping, and yes, the first GCF is 3p. What's the second GCF? 2.
2 plus 5.
Okay, so we rewrote the middle term. Now, we pull out that GCF, that yellow piece. Well, when we pull out that GCF, it becomes 3p times p minus 3. We pull out that common factor of 2, that becomes p minus 3. Now, if we look at this, what's inside the parenthesis is the same thing. If you get to this point and it's not the same thing, stop, because you can't go any further. You have messed up somewhere. You have got the wrong factors. You can't do this. So it's telling you, this is a dead set giveaway. If these two things are not the same, go back and refine two factors that give you that term. Now, also, here's the difficult part. Not every polynomial can be factored. Okay? There are going to be relatively prime polynomials. Okay? This comes into the next part when we solve quadratics. You are going to solve quadratics by factoring. Not all quadratics can be factored, though. Okay, so keep that in mind. That works, but it also is not the most efficient sometimes. Okay, now, once we have that common factor, we pull that out, p minus 3. Well, when I pull out that p minus 3 factor, I have 3p plus 2. And yes, that sign goes with. Okay, that sign goes with.
The beginning. First.
Yeah, it's Mac, man.
So starting the teacher line.
Okay.
Teacher line.
So when we pull this piece out from both, it goes here. What's left is the 3p. What's left is the plus 2. And now you've got the same factor.
Well, why does it work like that?
What do you mean, why?
Someone made it like that before. Why does it happen?
Why does this process work?
Yeah.
Because it's just taking what you've done with your FOIL and going backwards. So where you did first, okay, where you did first, we are factoring those two things. We're pulling those two things out. When you did outer and inner, we're taking those 4 terms and we're creating those 4 terms. And then we did our last and we're creating our last. So we are having this. So we started here, then we got this, then we went to here. FOIL, we start here, we go here, and then we go here. So it's just a reverse of the operations of your FOIL. Okay, so p minus 3 times 3p plus 2. Sorry about all those black dots all over.
It's like almost.
All right, so you got 4. Now, this one. What do you notice about this?
No GCF.
No GCF. It's the difference 2 squares.
No coefficient.
No, it does have a coefficient.
On the square.
It does have a coefficient though. What is it?
1.
The leading coefficient is 1. When the leading coefficient is 1, we can still do this AC method. You have done these. We did these earlier this year. So when we do this, when we have the leading coefficient of 1, it just simplifies the entire process. Because what is any number times 1?
Same number.
Itself. Okay, so we just go, when we have that leading coefficient of 1, we skip all this. We just say, okay, what factors of C add together give me B? What two numbers multiply to give me 4, add together to give me 5?
1 plus 4.
1 and 4. So,
A, B, C, D.
so the only way to get B squared, what's the only way to get B squared? B and B. So we have B times B. Well, we want to get 4. Two numbers that multiply give me 4, add together give me 5.
4 and 1.
A positive 4 and a positive 1. And you're done. So when the leading coefficient is 1, it makes life a lot easier. But you are still doing the AC method.
My life is already pretty easy. I can cheat.
Yeah.
Did you go one slide back?
One slide back.
Oh, the game good today. Oh, the game. Oh, it's so. Work out.
Are we good?
Hey. There we go. It's young. You wanna go out? Young.
No, he got
Okay, there are your 4 problems.
Do the problems.
Use your progressions. Okay, use your progressions. Start at the GCF, then check for a difference of 2 squares, then go to your AC method.
What is this Asian?
Dude, he do that.
Yeah, you did not.
But he said there are 4 problems. Oh my.
Oh, see what he did there? I don't pay attention to anything you say.
Let's do this.
4 and 10.
I know you.
Don't let me go.
5 and 8.
Don't let me go. I made
So we did this one. And then this was. Bye.
72.
Z squared plus 13Z plus 40. Okay, catching fire, that's enough. Alright. So Z squared plus 13Z plus 40. The coefficient of 1. What two numbers multiply to give me 40, add together to give me 13?
8 and 5.
8 and 5. So we got Z plus 8, Z plus 5. Okay? How about down here? Leading coefficient of 1, so we go to 72. Two numbers that multiply to give me 72, add together to give me negative 17.
Negative 9 and negative 8.
Okay? Only way to get x squared, x negative 9, x negative 8. Okay?
So just do 100.
Over there
GCF.
is what?
3.
3. So we pull out that GCF. So I pull out that 3, that becomes y squared minus 7y plus 12. Do not drop off the GCF. Gentlemen, pay attention. Do not drop off that GCF. The GCF is part of this. Okay? It is part of the problem. So we've got to carry him down. So now we have that 3 sitting out in front of our set of parentheses. Okay? Well, now we're back to a leading coefficient of 1. What two numbers multiply to give me a positive 12?
Negative.
But add together give me a negative 4. Or excuse me, negative 7. Y what?
Y minus 4.
Times y
Minus 3.
minus 3. Okay? If you remember back some of the early stuff when we were dealing with quadratics, quadrilaterals, we solved these simple leading coefficient of 1 quadratics. Okay? Back then we used the quadratic formula. If you were comfortable, I told you could factor these, but we didn't go through the rules for factoring. These are the quote unquote simple ones. That doesn't mean that they're easy. They kind of are easier. All right. Now, because it can't stay this simple, we got to step it up. We got to kick it up a notch.
Oh my god.
Oh my goodness.
So you got 4 more. Go to your regression. Look for a GCF. Look for a difference of 2 squares. Look for asymmetric.
Sister. I have a question. Like, I'm gonna follow that, like, relearn this.
I'm using his Bible.
Both math and bio.
Now I know why you're getting on these.
I was just confused also. And bio just I get confused with math. Just like, wait, no, this is
First one is
yeah, the
10 and 1. Second one.
one, right?
Making hard, but
I mean, you are there.
Shall we do this first one together?
sure. Yes.
No?
Your choice.
I always just go with it. What they say.
Alright, I'll give you some.
Yes, it's yours. Then how are you going?
Yeah.
Up.
You're gonna get.
Everything is okay.
First
Okay.
3 times,
Well, dude, did you go to all the sizes?
Yep.
All 3 will be. That's true.
I like tracking similar, like, yeah.
What?
If you make like volleyball, that
Dude, I'm 15.
Alright, let's work through the first one. If we have 2x squared plus 11x plus 5, what's our A? 2. What's C?
5,
Positive 5. 2 times 5 gives us what?
10.
10. 2 numbers that add together, multiply to get 10, add together to give me 11. Are what?
11.
10 and 1.
10 and 1. Which one do you want to go first?
1.
1. So we have 2x squared plus 1x plus 10x plus 5. 1 plus 10 gives me 11, so far so good. What do these two things have in common?
X.
Pull it out. What's that?
2x plus 1.
What do these two things have in common?
5.
Pull it out. What's that?
2x plus 1.
Did we do this right?
Yes.
How do you know?
Because you have to do the same thing.
You got 2x plus 1,
X plus 5.
x plus.
Smart.
Yeah,
Because that's.
That's when you pull this out, you left with x plus 5. I told you, if you don't give this stuff 100% attention, you don't really know where it's coming from. Sure about that?
No, I have to be stuck with your mouth.
I am so smart. I am so smart. I'm gonna make a song about being smart.
I posted on YouTube 1 like.
One night.
No. 100 unlike this.
But then what am I gonna do without your intervention? And then mathematics class.
Yeah.
What time do you come back on Sunday? 4 a.m. Actually,
We come back at like no, we come back at like 16 times. That's 4. Yeah.
Alright, have we got it?
Yes, socks.
Here's somebody over here. Who's got this one?
Me.
No? Anybody? What'd you get? Yeah. 2a plus 1 times 2a plus 3. Yes? Agreed?
Yes.
Okay. Oh, this one, 14x squared plus 33x minus 5.
That one's 35 minus 2.
What's the answer?
Oh, 7x minus 1, 2x plus 5.
Agreed or no?
Indeed.
Okay. 8m squared minus 10m plus 3.
2m minus 1 and 4m minus 3. I told you,
Sure or no?
I mean, you on how I'm smart.
Well, let's not go too far. Because this is just the starting point. Because now,
OMG.
this is taking to the next part. Now we're gonna solve the quadratic. Well, this is already factored. Well, now, if it's factored and it's equal to 0, how do we
Oh, I
solve it?
know what to do. Make each term equal to 0. Why? Because Mr. X told me.
Because anything times 0 is 0.
Because when you multiply two factors together and they give us 0, that means that one or both of these has to be 0. So I can take these separately, set them equal to 0, and solve them independent of each other. Okay? Same thing over here. So this, when we take it to the next step and we factor, when we solve these quadratics, the thing that we have to keep in mind, before we can solve, before we can factor, before we can do any of these things, pulling out GCFs or anything, the one thing that we need to do is get our quadratic equal to 0 before we solve. Okay? So we get this thing so that it equals 0. So we get everything on the other side. Once we get that, then we can go back to our factoring numbers. So if you look at the problems 1, 2, 3, 4, they're already done for us. So we're going to skip those. We look at 5, 6, 7, and 8.
Make it equal to 0.
So the very first thing is we set it equal to 0. So we take a look at number 5. It says 3k squared plus 72 is equal to 33k. We don't want it equal to 33k. We want it to get equal to 0. So how do I get this 33k over?
Negative 33.
So we subtract it from both sides. So we subtract the 33k. Now, we get it in this form. So put it in this form. 3k squared minus 33k plus 72 equals 0. Now we're in the form that we need to be. Now, is there a GCF?
We know, we madam.
We, 3.
Yes, how do you guys, what's the division rule for 3?
Equals 6.
Hmm.
Equals anything that can be divided by 3.
So, is 3 divided by 3?
Plus, if you add both of them.
33 divisible by 3.
11.
7 plus 2 is what?
24. 9.
7.
9.
9. Is 9 divisible by 3?
Yep.
Then 72
Oh, I didn't do that. So
So, I don't know. So we pull out the GCF. When I pull out the GCF, whoops, we got k squared minus 11k plus 24 equals 0. Now, if I have 3 times this equals 0, this is the case. So pay attention, you're gonna miss this, I'm guaranteeing. Once you divide out that 3, once you factor out that 3, you are solving. So give it to the 3. How do I give it to the 3?
Divide by 3.
I divide both sides by 3. 0 divided by 3 is what? 0. When we divide by 3, we get that 0 still. Now, we got a leading coefficient of 1. 2 numbers that multiply give me 24, add together and give me negative 11.
Negative 8 is negative 3.
Negative 8, negative 3. So it's k minus 8, k minus 3. Well, if it's k minus 8 and k minus 3, what's k got to be to make 0?
8.
What's k got to be to make 0?
8.
8. 3 are your answers. Okay? Now, if you went all the way back up here, got it equal to 0, did your quadratic formula, yes, you still could get the same answer. Okay? Yes.
So if you plug those numbers into that equation,
You will get a true answer. If you put 8 in here, you squared 8, multiplied it by 3, add 72, you put 8 in here, 33 times 8, it's true, it works. Same thing for 3. Now, this works. I'm not going to tell you how to use your algebraic solver on your calculator, you can figure that out. That's not as useful as the second part that I'm going to tell you. You can take your calculator and you can graph these and you can get 8 and 3. Okay? Once you get it equal to 0, okay? Once you get it equal to 0, replace that 0 with your y, or f of x. You guys all have TI inspires. So it's f of x equals 3x squared minus 33x plus 72. So get out your calculator, put that in right now.
Yeah, they put that in.
Okay, guys, put it in a calculator.
If you don't have your calculator, pull out your computer and put an online graphic calculator.
So it's like I'm getting a new calculator 3 weeks.
Because he lost his.
You were asking something.
He's like, don't worry, I'll take 3 different one. I gave you 4.
So if you go to your home screen,
Like that.
if you go to your home screen, you just go to the graph, same place that we did our inequalities and our systems graphic, same place. You can clear out all of those things. Okay? So now,
It's like a whoop.
I don't even know what the whoop means.
What
Let's put it as square.
You put the x by the square button, the x button is a button with the three buttons inside.
You pretty much what it is.
It becomes more. Why is it like 3 and then this?
Yeah, which is very good.
Oh, 3x.
How many of you guys know what the graph of a quadratic is called?
It's called a loop.
It is called the curved line.
Lines are straight. There's no such thing as a curved line. You can tell that from this kind. A line is a line. They're all straight. Not curved. A curve is a curve. Okay. The graph of a quadratic is called a parabola. Okay, and it has a U shape. Kind of talked about this before. How many possible solutions can this quadratic have?
2. Infinite. 0. 1.
Which one? How many possible solutions can you have with a quadratic?
8.
2, 4, 3.
3. What are the possible outcomes?
No solution, one solution, and 2 solutions.
When are they?
Okay, so no solution is when the lines are parallel.
We're not talking about lines, we're talking
Oh,
about
when the lines don't touch the axis.
the x-axis. Okay, when your parabola does not touch the x-axis. How many situations can that be?
4,
Infinite.
1.
2. Because if this is your x-axis, you can have your parabola above opening up, or if this is your x-axis, you can have your parabola below and opening down. How many times does that touch your x-axis?
None.
0. So the solutions means the same thing as roots, which are the same thing as x-intercepts. Okay? Solution is the same thing as a root, is the same thing as an x-intercept, is the same thing as a 0. All 4 of these terms, ladies and gentlemen, all 4 of these terms are synonymous. And yes, you must know that when you talk about a solution, you talk about the roots of a quadratic or the roots of an equation. When you're talking about the roots, you're dealing with the x-intercepts. When you're dealing with the x-intercepts, that's the zeros. The y's are 0. Okay? So all of these are the same. Well, these are 2 of the situations that can happen. Well, if it's not like that, well, what happens if it is below and opening up? How many times does it cross the x-axis?
Twice.
How many times does it cross it if it's above and opening down?
Twice.
So there's 0, 2, and then it could be the x-axis, then it comes down and it touches it 1 time. And this is 1. There is a way to determine how many solutions that a quadratic has, and it's called the discriminant.
B squared minus 4ac.
What does that mean?
You put
It doesn't do you very good to just memorize things if you don't know what it means.
That's my math teacher.
Your stuff, right?
Oh,
Also, the equation in this is it's organized like ax plus.
remember, we've got to get this thing down into ax squared plus bx plus c. Well, before we start talking about factoring these things, we had, well, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, where do you see the b squared minus 4ac?
Square root of b squared minus 4ac.
You see it under the radical, which is why you have 3 different possibilities.
Whoa.
Okay? Because what happens when b squared minus 4ac? How many different possible numbers can that be? How many kinds of possible numbers can that be?
3.
What are those 3?
Positive, negative,
0.
Positive and negative and 0. So what happens when b squared minus 4ac is positive?
That means 2 solutions.
Why 2 solutions?
Because
Because you can take the square root of a positive number. What happens when you take the square root of a positive number?
It's positive.
You get a number back. So then I take this negative b plus that number divided by 2a. I take the negative b minus that number divided by 2a. I get 2 solutions. Well, if it's not positive, what else could it be?
Negative.
Negative. All right, I'll do 0 first, and then negative. Well, if it's 0, what's the square root of 0?
0.
Negative b plus or minus 0 would just be negative b. Negative b divided by 2a. How many solutions is that?
0.
1.
1.
Oh, yes, boss.
Well then, what happens when I take the square root of a negative number?
You get.
Negative. Like,
I do not get a negative.
like undefined.
I get an
You
imaginary.
get I.
I get an imaginary number. I is only the square root of negative 1. But I get an imaginary number, which makes this a complex number, and we don't deal with complex numbers in our real number system. This is 0 real solutions. Okay? Yes, next year you will deal with imaginary and complex numbers. Next year you will find the solutions to these parabolas in these two situations that are going to give you complex or imaginary values as the answer. But we are not dealing with imaginary numbers right now. We can wait until next year to deal with that. But what we will say is we can, and this is part of what you will be assessed on, how many possible solutions does this quadratic have? And you'll need to be able to tell me whether it's 0, 1, or 2 solutions. I will not ask for those solutions. I will just say how many solutions is it? So be able to tell me by using this discriminant. Now, dealing with the discriminant, you also have a second way, an archaic way, or a always go-to way. This will solve any quadratic.
But why?
Because this is the way that it works. And this quadratic is derived actually from, this quadratic, this formula comes from, it comes from there's a little bit of calculus involved in this to get here, but it's coming from all the possible solutions. Yes.
How do you know, because usually we solve there for 2 solutions, but how do you know if it's 1 or 2?
By just looking at this b squared minus 4ac. The a, b, and c are these a, b, and c. So if I take this b squared minus 4ac, if this discriminant is a positive number, I know I have 2 solutions. That means I have this situation. Okay? If it's 0, then I have, this solution, 1 solution. If my discriminant is negative, then I have 0 solutions. The discriminant is this guy, b squared minus 4ac.
Oh, you mean if you plug in the number?
If I put in the a, b, and the c, in this case, 3 is a, 30, negative 33 is b, and 72 is c. If I did this, then this discriminant would come out to be a positive number, and therefore I know I have 2 solutions. Now, our next step with quadratics is to graph them, to go through and graph these things. There are some tricks and some things that we're going to learn from graphing to be able to determine which of these situations we have from that just looking at the equation. We don't have that yet. Once we get comfortable with that, I won't need to go through this discriminant because I'll be able to look at it in an equation and I'll be able to say, okay, this thing is above and opening up, below and opening down, below and opening up, above and opening down. Or it's going to be on the x-axis, opening either way. So there are going to be some tricks that we're going to go through when we get to graphing that will help eliminate going through the process of the whole b squared minus 4ac. Okay? So, now, you've got old school, will solve any. I hate calling it old school, but because some of them can't be factored, and sometimes you're not going to have your calculator, so you can't check the graph. Okay? You can, however, get a table of values and get plot some points and get an idea on a graph, on a paper graph, what this thing looks like. Yes.
If you put the stuff that makes it that we get the same answer. Like
What do you put the what?
if you put like number 5 into that equation,
Yes.
we still get
Yes, because this right now, you have your calculator out. What I want you to do is I want you to put in this guy right here. You will get the quadratic, you will get the parabola for this function. Okay? Where is this thing? What kind of graph does this look like? Which one of these does it look like?
2,
So let's go 1, 2,
3,
4, 5, or 6. Which one of those?
3.
So it's below the vertex, that's the single point, the vertex. It's below and opening up. So it touches 2 times.
Yeah.
The way that we find those 2 is almost identical to the way that you found the point of intersection for your systems. Go into your menu. Okay? In your menu, get your calculators out. Get your menu. And the menu for your graph. Find, or there's going to be a subtop that'll say analyze graph.
Intersection.
Okay? Not intersection. 0. What I want you to find is the zeros. Okay? You gotta set the lower bound, you gotta set the upper bound, just like for when you did your intersection. Lower bound is B to the left, upper bound would be to the right. Okay? So as long as your boundary, as long as your zero is between your boundaries, you will find it. And you should be able to verify that you get 83. Okay, so if you have a graph and you can't see it, go to your window settings, and zoom out. Or zoom fit, and that'll change the way that your viewing screen looks.
Is answer 30?
Mine was a street run.
Yeah.
It's not, it's this portion. So then you're-
30 and 80. Oh, run that on the run that.
Yo, so sure like the both you. Yo, everything's yo. This yo. What's wrong, Homer?
Free time.
What is the thing? Look at this. Please. Oh, I'm sorry. Masa.
Shooting so dumb, boy.
I just wish I could have that. Yeah.
You just wish.
Oh yeah, you never gave us.
And like 24. What?
So you have Okay, so what you have, this I have posted. So I want you to start number 5 and I want you to do the rest of these.
Right now?
You can get them done in 2 minutes.
Okay, I'll try.
Now, what I want you to do is, I want you to do a mix. I want you to solve some of these by using your calculator. I want you to solve some of these half and half. Solve half of them by your calculator, solve half of them by hand. I don't care if you go through every single one of them and solve them by doing this. This is gonna take time, so I would at least say do a couple of them by factoring. All of these quadratics here, they can be factored. Okay, you're not gonna run across any that cannot be factored on this page. Okay, so you have 3 ways to solve things. Right? So the next time that we come, I might give you a 1 or 2 question quiz on solving quadratics, but then we're gonna jump right into graphing. Okay, and then we're gonna graph by hand, we're gonna graph by paper. So next class, make sure you have your calculator.
So if you solve my calculator, you just write the answer.
Yep. I'll give you there. And I've attached this to your Google Classroom, and the answers should be attached to that. All right, good, you got these done, that's fantastic.
Thank you. It's like initial solving systematic equations.
Why don't you rule with the
Yeah, why don't I do with age?
Oh, it's age group.
We need to choose this.
It is chosen.
What's